Cedar, Ayla, Nargis, Beasley, Fani, Bulbul, Amphan, Jawad, Remal. What do you think? What are they? Are they my friends? You were wrong. All these are the name of devastating cyclones that hits the coastal region of Bangladesh and India in recent years, and this happens every year. Today, we're diving into the world of cyclones, their devastating impacts, and the crucial role they play in shaping the coastal and mangrove ecosystems. Stick around to learn about the powerful forces of nature and their far-reaching consequences. Cyclones, also known as hurricane or typhoons, depending on where they occur, are among the most destructive natural phenomena on Earth. Each year, approximately 90 tropical cyclones form globally, causing an annual average of $26 billion in damage and resulting in the loss of over 1.9 million of lives over the last century. There are normally 5 categories of cyclone based on their strength. In Category 1, the wind speed is 74 to 95 miles per hour, and that is very dangerous. And in Category 2, wind speed is 96 to 110 miles per hour, and that is extremely dangerous. Winds will cause extensive damage. And in Category 3, wind speed is 111 to 129 miles per hour, and that is devastating damage will occur. And in Category 4, 130 to 156 miles per hour, and that is catastrophic. And in Category 5, 157 miles per hour and higher. That is extremely catastrophic. These powerful storms are characterized by intense wind, heavy rainfall, and storm surge, which often led to catastrophic outcomes for coastal regions. And how the cyclones forms? Well, the initiation of depression or deep depression over the ocean does not indicate the cyclone formation. Tropical cyclone is formed when surface wind speed around vortex is at least 17.5 meters per second. 6 climatological parameters are required to form a cyclone: low-level relative vorticity, inverse of the tropospheric vertical wind shear, and the Coriolis effect, and surface temperature exceeding 26 degrees centigrade, moist static instability, and mid-tropospheric relative humidity. Background necessity for cyclone formations are monsoon trough location, favorable 6 environmental parameters, wind surge to the pre-existing disturbance, in intensification of mesoscale convective system and associated mesoscale convective systems. The Bay of Bengal has warm sea surface temperature, typically above 28 degrees centigrade. This warm water is crucial because it provides the energy needed for cyclones to form. Warm water heats the air above it, causing the air to rise and create a low pressure area at the surface. Due to Earth's rotation, the Coriolis effect caused the rising air to start spinning. In the northern hemisphere, this spin is counterclockwise. Winds from surrounding high pressure area rush into the low pressure zone. These winds also start to spiral due to the Coriolis effect, feeding more moisture and heat into the system. As the warm, moist air continues to rise and cool, it forms clouds and releases latent heat, which further lowers the pressure and draws in more air. Their positive feedback loop intensifies the system into a tropical cyclone. The cyclone grows as long as it remains over warm water and favorable atmospheric conditions, such as low wind shear, which can disrupt cyclone's structure. Coastal areas are particularly vulnerable to cyclones. The combination of strong winds, high tides, and storm surge can devastate communities, infrastructure, and ecosystems. In Bangladesh, cyclones have caused over 50,000 deaths in the 1960s alone. The infamous 1970 Vola cyclone claimed more than 300,000 lives, making it the deadliest cyclones on record. A study on Cyclone Cedar in 2007 found that it resulted in nearly 4,406 fatalities, injured over 55,000 of people, and caused approximately $839 million in damage. The storm surge inundated over 1,800 square kilometers of land, destroying crops, homes, and livelihoods. Impact on coastal area can be measured through vulnerability. This vulnerability depends on exposure, sensitivity, and adaptive capacity. Now, what are these? The indicator of exposure are elevation of terrain, soil slope, distance from coast and floodplain, wind speed. An indicator of sensitivities are population, age, health, gender, wellness, fitness, mobility, occupation, lifestyle. An indicator of adaptive capacity is access of information, education, transportation, insurance, finance, evacuation plan. A recent study says exposure is very low in the northwestern region, especially in the part of Zashor, Khulna, Norail, Gopalganj, Bagarat, and some parts of the Cox's Bazar district. Very high type of exposure region can be seen in the districts like Chandpur and Lokhipur. Districts like Barguna and parts of Chittagong as well as Cox's Bazar are the moderate type of exposure zone. High type of sensitivity can be seen in the districts like Noakhali, Lokhipur, Chandpur. Adaptive capacity is very low regions close to the sea such as Cox's Bazar, Satkhira, Bagarat, Noakhali, Bhola, and etc. Mangrove forest plays a vital role in mitigating the impact of cyclones. This unique ecosystem acts as natural barriers, reducing the speed of energy of storm surge and protecting inland area from flooding and erosion. Studies have shown that areas with dense mangrove cover experience significantly less damage during cyclone. For instance, during Cyclone Aila in 2009, regions with the intact mangroves in the Sundarbans experienced lower damage level compared to those without. A comprehensive analysis revealed that mangrove forest can reduce wave height by up to 66% over a 100-meter stretch. Additionally, mangroves sequester large amount of carbon, making them crucial in the fight against climate change. But unfortunately, mangrove forest in Bangladesh is getting reduced day by day. The Sundarbans mangrove forest covers an area of about 10,000 square kilometers. 60% of this forest is in Bangladesh and another 40% is inside of India. Approximately 200 years ago, the Sundarbans measured about 16,700 square kilometers and was home of several species like Javan rhino, wild buffalo, swamp deer, barking deer, leopard, and many more. Now all of them are completely extinct. The major threat for this mighty forest is rising temperature and rising sea level, cyclones, increasing salinity, and change in agricultural pattern, deforestation, and pollution. A recent study says in 2001, dense forest was 1,655 square kilometers, and in 2009, the forest was 1,651 square kilometers. Dense forest decreased within the few years. It was 4.5 square kilometers. Degraded forest were 404 square kilometers in 2001, and in 2009 it was 332 square feet. Climate change is expected to exacerbate the frequency and intensity of tropical cyclones. Rising sea surface temperature provide more energy for cyclone formation, while higher sea levels increase the risk of storm surge. According to the IPCC, the intensity of cyclones is projected to increase by 2 to 11% by the end of the 21st century. The destructive power measured by the Saffir-Simpson scale is also expected to rise, leading to more Category 4 and 5 storms. To mitigate this risk, comprehensive studies are needed. This includes preserving and restoring mangrove forests, improving early warning systems, and enhancing community resilience through sustainable development practice. Globally, the impacts of cyclones vary, but the underlying threats remain consistent. In India, the coastal state of Tamil Nadu has developed multi-criterion analysis to assess cyclone risks, helping to better prepare for further events. Their approach includes factors like socioeconomic condition, infrastructure resilience, and environmental protection. Here, GIS and remote sensing technologies can be used combinedly with machine learning and deep learning to map cyclone exposure, vulnerability prediction, and forecasting, also aiding in better disaster management planning. Cyclones are a formidable force of nature, but with informed strategy and collective actions, we can mitigate the impacts. By understanding the science behind these storms and investing in the natural defense like mangrove forest, we can protect our coastal communities and preserve the delicate balance of our ecosystems. Thank you for joining us today. If you found this video informative, don't forget to like and share. Stay safe, stay informed, and see you the next time.